So for those who just joined, so please scan your attendance because I'm going to disable the attendance at 2:20 p.m. Okay, done. So I'm going to deactivate the QR code now. Puluh orang je. Okay, can you see my screen right now?
Yes, doctor.
So basically, for today, we're going to continue on what we did last week during our last class. And last class, we already go through on how to program the Arduino using the MATLAB Simulink. And then we already go through the example on the LED, the servo, and the potentiometer. And then so far, any questions? So anybody already tried and having problems? So any question? Okay, good. I'm assuming that there is no problem. So we're going to continue today. So today we're going to go through on how to create a graphical user interface within Simulink for for interactive for interactive communication between the software and hardware, which is your Simulink. But later on, we're going to see at what extent that you can use this graphical user interface with your Simulink. Okay. So for today, first part of today's lecture, we're just going to go through on how to create a graphical user interface, just a software, and make it operate the virtual LEDs. And then later on, we're going to integrate this graphical user interface of the LEDs with the actual LED on the Arduino board. Okay. Okay. I'm going to open my okay, this is the Simulink. So usually when we want to create the graphical user interface for Simulink, either to use it only for or just for the Simulink models or with the Simulink or Simulink Arduino, most of the blocks actually came from this one, dashboard. Okay, dashboard. So we have several boxes where we have callback function, checkbox, combo box, custom gauge, dashboard scope, display, edit, gauge, half gauge. Then we have horizontal gauge, we have knob, we have lamp, we have linear gauge, and then we have a multi-state image, and then we have push buttons, then we have a quarter gauge, radio button, rocker switch, rotary switch, slider switch, a toggle switch, and vertical gauge. So you need to remember, if in Simulink everything already being categorized, especially for in Simulink we have a good example of where the block of inputs being categorized on the sources subcategories, while the output being categorized under the same category. Okay, but in the dashboard everything be mixed up. So you need to familiarize yourself which blocks or which graphic GUI blocks can be used as input and which GUI blocks that being used as the output. Okay, and we're going to go through a simple example for you to familiarize on how we can use these dashboard blocks. Okay, the first one okay, and then the first thing I'm assuming that you already familiarized with the how to use other Simulink block as well, because most of the Simulink block that we learned previously is also going to be used in this example. Okay, now okay, now to create, usually for graphical user interface we have should have the like a small window, and then we have the categories, we have the title. Okay, so we're going to start with this one first. Okay, let's say that I'm creating the control panel for the LED. So just select this one, resize. Okay, then I want to change the color. So go to properties. Not here. Okay, area color. This one you have a custom. Let's say make it as a gray. Okay, okay, then put some text. Okay, and this for LED example for this software, it's just that I'm going to to switch on and switch off the virtual LED. So when I toggle on this LED, so the LED going to turn on, and then when I toggle down the LED going switch off. Okay, so for that we need the toggle button. So later on you can use. There's a lot of variation of toggle button. You have toggle switch, slider switch. You have a rotary switch, rocker switch. Okay, and then this one depends on what you want to use. Okay, so for the first one, we just going to use this one, toggle button. Okay, and then we put the LED or lamp. So this one representing the light. So basically, we have two color. So let's say this is example one. So copy, and I will just use one. Okay. Okay, now we need to connect. So this is our input and this is our output. So if you double click this one, there's two state over here. So we have state one, and then we have state two. Okay, when we switch on the value, we toggle the switch to upside direction, the value is going to be one, and we switch off the downside values, the value is going to be zero. Okay, and then if you take a look at this one, if we double click this one, okay, we ask you to display a color that reflect an input value. So what you can do is that you want to link this GUI to this block to this block. So basically, what you need to do is that just double click this one, select this one. Okay, sorry. In between, we need to have the Simulink block. Okay, for example, um, okay, we need to use a continuous block. Okay, we use this state. Okay, how it works is that whenever we click this toggle button, the value either is going to be one or zero. It will be updating the value inside the constant block. and then the value deformed. The constant block will be used to change or to switch the color of the LED. Okay, since that this is a simulating block, so there must be we need to sync this value. Okay, we need to sync it. Okay, to sync the signal because we're not going to use the value, so we use terminator just to yeah. Okay, now you can do this one. So just double click toggle. Okay, we ask you the which signal that you would like to what to change its value once you press the toggle. So what you need to do is that just click the area of this white area and then click the block. Okay, okay, okay. Now select apply. Okay, it's already on. So if you take a look over here, if I switch off the toggle button, so it's going to change the value automatically. Okay, now for the LED, the same thing. We just need to select the white area, this one, select the value over here. So you need to do it. So sometimes you need to close the V block if nothing is coming out from it. Sometimes uh, because of the what? Okay, ada. So usually sometimes it will take time. So just okay, just you need to what click it as for several times or just wait. Okay. So in this case, I'm already select this constant block. So I just need to select the connect button over here. So we're going to have right now what we want to do is that once we toggle on the switch, we're going to change to one color. And if you toggle down the button, which is switching it off, so you're going to switch on to other color. So in this case, we can modify this one as a green color, and then okay, so add another one. So 0 for red color. Set. Okay, done. Okay. So for simulation, since that we are not integrating this one with Arduino yet, and we don't have to do that because this is a pure simulation. But we want this thing to run continuously until we stop it. So for that, we need to mention that this simulation is going to run for infinite time. So we just put INF at the stop time. So then from there you can just run. Okay. Okay. Later. Wait. Super. Okay. Eh, aku tak boleh. Sekejap. Sekejap, eh. Oh, dia tak ada. Okay. Now we just going to run it. separately. If you want to know the try another method. I'm not sure why it's not working. So you can start playing around while waiting for me to figure out what's wrong with this. So okay, usually yeah. Uh, oh, oh, okay. This one, uh, this one need to be connected to this one. Okay, I think I know the problem. Okay, let me check. Okay, then select this one. Hmm. So anybody already do it and have no problem? Oh, buat jadi kan? Tak ada error kan?
Jadi doktor.
So same sama yang cara saya buat kan? Cuma saya tak tahu kenapa saya punya saya punya ni ada masalah. Ya. Ya, saya nak tunjuk yang mana yang tak dapat tengok ni. Okay. Okay, yang mana boleh cuba buat, boleh cuba buat. Saya pun tak tahu kenapa saya punya ni ada error. Sepatutnya dia simple example ni dia tak ada masalah. Okay. Oh, saya tak tahu lah. Kenapa? Ya. So kalau macam ni have a problem, saya tutup je, saya buka balik. So yang lain boleh cuba dulu lah. Play around. Saya nak tengok apa masalah saya punya MATLAB version ni. Okay. There's no data coming in. Maybe second. So siapa yang belum nampak lagi? So anybody who haven't got what I'm trying to show? Oh, okay. Saya rasa saya punya ni lambat sikit lah. Saya cuba tukar value ni sekarang ni pun dia tak boleh. Sepatutnya dia tak jadi macam ni. It shouldn't be like this lah. Ya. Tu. Sekejap. Okay. Okay. Sekarang ni berapa orang yang dah buat dan dah jadi? So tadi berapa orang? Okay. Saya rasa ni something wrong dengan saya punya ni laptop lah. Dia punya processor. Okay. Good. Okay, so majority dah jadi ya. Okay, good. Tunggu sekejap. Saya nak tengok kenapa saya punya ni tak, dia tak apa, saya punya block LED ni dia tak switch colours. Okay, yang lain tu boleh play around lah. Saya nak tengok. Saya nak troubleshoot kenapa saya punya ni. So, meanwhile awak boleh play around. Okay, for those who already make it, okay, you can start playing around on how to connect the simulink block to the what dashboard blocks, either it be input or the output of the dashboard. Okay, so for example, if you let me do this one first. Okay, you can play around. Let's say that you want to put a casing. This is your source. So make sure for any block that you want to use as input, make sure you need to have a terminator block. Okay, just to make sure that the signal or the inputs only be used just for the purpose of the grid block, and we don't want the signal uh, to give an error, because improperly connected signal lines just going to cause an error in your simulink. So just to avoid that, just put the terminator block. So in this case, let's say that I'm trying to use a sine wave. So I'm not going to process this sine block with any algorithm or mathematical equations. So I just want to see the signal only, and I don't want to use the scope. So what I use is that is a dashboard. I'm going to use dashboard scope. So you just need to collect this one. Just double click the dashboard scope, and then make sure you click the sign. Okay. Okay. Okay, ada yang kawan awak cakap yang mana tak boleh. Kalau tak pakai terminator, awak letak je scope. Mungkin boleh. Okay, jadi saya cuba awak punya method. Saya pun tak tahu kenapa. Tapi last time saya pakai ni okey je. Ya, tak apa. Jap. Okay, so saya buat infinity. Click one. Okay, just one. Oh, okay. Maybe saya pakai ni kot. Terminator block. Cuba kawan awak punya. Saya minta kelom. Ya. Okay, yang lain semua dah cuba. Boleh buat tak? Okay, yang mana tak boleh, kalau punya blog tu awak run, tak boleh. So ikut cara kawan awak, instead of using terminator block, awak just change, use scope. Okay, scope block. Okay, sebelum awak connect dengan dashboard punya block lah. Saya pun tak tahu kenapa dia tak keluar-keluar lagi ni. Okay, sign with. Okay, apply. Okay, keluar. So sekarang ni saya nak troubleshoot, boleh tak pakai Terminator. Oh, nampaknya memang tak boleh lah pakai. Okay, so we need to use other than Terminator as long as it's complete your signal lines. Okay, so just don't use Terminator block. If not, even though that we are what we meant is this block, so just going to consider that the signals already be terminated, so it will not be used in during your simulation. Okay, so thank you yang figure out ni. Okay, so kita patah balik ke kita punya example tadi. Okay, dashboard. Okay, go to LED. Custom. Okay, betul lah. So kita tak boleh pakai Terminator. So, okay. So semua dapat lah, dapat. Okay. Okay, now we go back to okay, GUI. So basically awak letak pin ni. So kita buat arrangement lah. So okay, so basically the reason why we're doing this, okay, katakan awak nanti bila, okay, block yang untuk dalam GUI, usually in GUI we only want to see the switch and the LEDs block, which is this one. And what happened to our Simulink block? So usually we're going to hide it. So the way that we are going to hide it is that we're going to select all the block and then create the subsystem. Okay, create subsystem and then make it small and put it anywhere on your GUI pane. Okay, there you go. So basically, but there's some shadow, so you just need to, you can make it disappear. So you don't go to format and then untick this content preview. So there you go. So this one later on you can hide it. Okay. So this is not our concern. So this is our concern. Okay. So this is the switch. Then yeah. LED is okay. Okay, put it over there. Okay, any question? Dapat Okay, now we're going to try another example involving simulating blocks, how we're going to connect and how we're going to arrange our blocks. Okay, let's go back to this one. Okay. Um, okay, previously in Simulink or in Simulink block, the way that I told you that in Simulink, the process flow is that Simulink flow. You need to have input. Okay, then this is the input will be processed. Then you then have your output, correct? But in a graphical user interface, we're going to have input and we're going to have our output. It's just that our process is actually being hidden out. Okay, it's just that our process being hidden out. So, teruslah. Okay. So this one, process being hidden. Okay, just okay, since that you cannot see it, that doesn't mean that it is not there. It is already there. It's just that being hid out, like the one that I show you in the LED example, where the blocks for the on and off on the constants being hide out. Okay, because in graphical user interface, what happened behind it, we don't want the what user to see it. We just want the user to have the control over the inputs and be able to see the outputs as when the input being given. Okay, now the way that we typically the way that we're going to use or do the arrangement on the input. So usually normal typical GUI layout. Yeah. So basically, okay, we going to have our window. Okay, and then you're going to have your input, and then you have your output. Okay, your input usually can have you need to it consists of two sections, one input and one output. Okay, either you want to arrange your input in the vertical direction, okay, like in this way, this direction, okay, and your output also in the vertical direction, or you want to have your input in arrange in what horizontal direction, okay, in horizontal, or you want to have your okay, either you want to have your this is you can have a combination. This one, let's say that this is a text input. Okay, this is a text input, and you can have this the way like this. This is your input one and input one and input two. Okay, this one can be just a text. Okay, text. This one is your switch. Okay, this is your output. Can be in form of your graph. Okay, or you can do okay. Then another one like this. Okay, this one is your input. This one is your input. And this one is your output. And then okay, so this one it can be in form of text input, and then this one can be in form of your switch input. Okay, switch input. So this is how the typical graphical user interface layout. So if you want to take a look an example of a graphical user interface, you can okay, this is a typical one, but there are also graphical user interface custom made to make it people easy to assess or control system. Is that some of designer, so what they did is that they have one big let's say interface. Okay, and then this is the system. Okay, so this is the system, let's say that a system of electric powertrain, the one that we'll be doing right now. So you have a powertrain. Okay, okay, so this position the every subsystem, let's say that for steering, so you're going to have a label for what it consists of control input, then status, or maybe what status, or what graph, or percentage. Okay, and then every okay, so every subsystem, let's say that this is the battery system. Okay, have the input of battery, and then its status, either it's on or off. Okay, SOC. Okay, this is like this kind of graphical user interface typically being used to control a system. Okay, to control system, meaning that you on off. The one that I showed previously, this one is uh, for for data acquisition system. Okay, this one we typically use this one for data acquisition system. Okay, data acquisition system. Okay, there are many ways. Okay, but this is the most typical one. If you want if you want to make it easy like this, but if you want to make interactive like this, so we have the whole system in the middle of your graphical user interface, and then any subsystem you want to observe, just label it, and then of course you have input, status, and graph. Okay, so let's say that this is for the battery. So we have later on you have the powertrain. So input, what are the input that can be controlled, what are the status, okay, which gears, okay, and then a graph or percentage or relevant information that you would like to access. Okay, so this is the what like the general rules of um, general rules for the graphical user interface that typically being used for research purposes. But for commercial purposes, usually they will have their own theme, okay, and especially on the scene layouts, the color, the buttons, okay, for the purpose of commercial, for commercialization. But for research purposes, usually engineers going to create a simple system, as simple as possible, as long as to ease data acquisition, to monitor the data, and then to be able to control the system easily. Okay, because if sometimes when we design things to look complex, when we have problems, then it takes some time to do some troubleshooting. For purpose of research, So this is the most practical one lah. So if you want, or if you can come out later on in your project, you can come out with a most intuitive or interactive graphical user interface, then it's up to your creativity. Okay, any question for this one? So any question? Yeah, no question. Good. Okay. Sunday, 25. Okay. Okay, ni untuk this question for a friend. For the layout that I just show you. So which layout is the best? So basically, there's no the best layout for you. So it's up to you. So which one that you are confident or convenient to work with, because it also depends on your amount of inputs, the switches that you would like to use, and also the graph. Okay, so it doesn't matter. There's no general rules. But the only rules that you need to understand is that the graphical user interface, it need to be good in terms of user friendly. Okay, so it need to be easy to operate. So meaning that whenever let's say that you are the one that been creating this graphical user interface, of course you're going to understand what does it mean, because you are the one creating it. It's just that when we are designing graphical user interface, so that when other people, so for those who are first time looking at it, seeing it, they will understand what does it mean. So meaning that so let's say that we categorize certain inputs in one row, and then the next row consists of its graph. So people will easily know what it means, because the graph will correlate with the input that being associated or being located or being put next to it. So it's easy. It's not that you put here and there, and then people what having problems in understanding what does it mean. Okay, so it doesn't matter the layout. So as long as what you make the graphical user interface, people can understand easily without the need of referring to manuals, and then should be okay lah, should be fine. Okay, the problem is that we usually in software, when you're operating software, we need a user manual, right? Because because in actual software, there's too many parameters. There are many ways to operate it. So that's why we need user manual book, or okay, okay. But for you, you need to make it as easy as possible, so that for this project, so that you don't have to have the user manual, so that whenever I and Dr. or Dr. Izahari take a look, or your friends take a look at it, they can pick it up without the need of referring to this user manual. Okay. Okay. Any other question? Okay. Now, okay, now we're going to go. Okay. Now we go to go for other example. Um, yes, you need to test. Not okay. This one you need to test, not because of to make it easy to use. No, you need to test because you need to make sure that it works. Okay, how to make sure that it's easy to use, that one very subjective lah, but usually easy to use, yeah, if you're familiar with that one, you can understand. But the most important thing, testing your graphical user interface, that you need to make sure that it works. Okay, it works first, and then once you make it work, if you see potential for your user interface to be further improvised, to ease the user friendliness element, then just do it. Okay, because this one for user friendly, and then yeah, this actually depends on creativity, and I cannot force or creativity. I cannot say that this one is good and this one is not bad. But okay, because if your limits is up to that limit, yeah, I cannot do anything. If your friends can do better, then it's going to be a extra bonus to that group lah. Okay, because creativity on making these things easy, so this one depends on your creativity. Okay, but the test is actually compulsory because you need to make it work. Okay. Okay. Any other question? Okay. Good. Okay. That's let me see all the block. Okay. What else you can? Okay. So basically, okay, this one vertical gauge is actually the input. Okay, this one is also input. Like for toggle switch, you just toggle the input. Maybe one or two. You have only two inputs. But if you want to use more inputs, okay, for so let's say that we demonstrate this one have multiple input. So you have off, low, medium, and high. Okay, I'm going to delete this one. Oh, no, I'm going to create a new one. So this one I'm going to it's okay. I'm going to create a new one. Okay, sources. So the concept for this one also same this one. Also the same as the toggle switch. It's just that instead of having only two inputs, either zero or one, you can have more than one, or you can have more than two inputs. Okay, and then this is going to be and each input, each selection of inputs going to give you different option of output lah. So in this case, I'm going to assign different colors for different stages. Let's say that this one is off is a one color, low one color, a medium one color, and high one color. And then for this one, you can actually put more than let's say that right now we have four, so we can add more states. Okay, more. Let's say that one, if let's say you want have a 360, so this one is already four, another. Okay, so off, let's say state one, let's say that two, three, four, five, six. Okay, so okay, so you can see if eh, I if I slide this knob so to this position, it's going to change the value. Okay, three, four, five, six. Now we just need to connect this LED to the value inside the constant block. Okay, now since that we have a six state, starting from 0, so we need to have a 7. Okay, so this one already 1, 2, 3, 4, 5, 6. Okay, okay, so this one we can hide it later, so just click run. Okay, so we have different colors when we change the lock buttons. Okay, I want you to try this one. Okay, got it. Tepat. Okay, good. Okay, can I proceed with the next example? Okay. Okay. Mm, okay, we're going to demonstrate. Okay, now we are actually looking at the inputs that drive the LED, the inputs only have 2 states or 6 states. So meaning each time we change the state of this button or this toggle, so basically the LED is also going to change. But what if you want to make something that works like keep on changing depending on when the state keep on changing continuously. Okay, let's say that we have this one. Okay, this one is constant. I need to make, in order to make my LED keep on changing, so I need to change the value. Okay, what if the value itself already keep on changing continuously, and then the color will be based on that continuous changes. So it's like when okay, so let's say another one. So this one belong to this crystal system. So this one, right? So this one belong to this one. Okay, next. Make it. So the reason why I'm doing this is that to make it easy for me to move the whole block in a group. Right? So like that. Okay, this one is to categorize my block. Okay, same thing with this one. So I'm just okay. I'm grouping my block. Okay, later on you can actually do proper grouping, make it adjusting the border of the pane for each group. Okay, this one also I'm doing. gray color. Okay. Then later on, next example is that yeah, still on the LDA example. So dashboard. Sorry, create this one. So green color. Use the LED. Then we have linear state. Then we have the simulink sources. The same that we have a uniform random number. Okay. Let's say minimum is a 0 and maximum is 100. Assembling time is let's say internet 0.1. Like this one. So adjust your tick interval be 10. Okay, and then in this one you have a scale, right? So meaning that maybe you can have a low region, medium region, and high region. So we're just going to maximum. But we're going to divide this region inside this state. So we have a random uniform number. So later on when it runs, you can see that the needles moving within the range that we set. Okay, of a colors. Okay, let's say up to 20. Maybe yeah, to 21 to let's say 60. 61 to 90. Time is green color. Oh, red color. Okay. Okay. Uh, okay, and then we put some scope. Nice. So just put anything. So this one I'm going to put 20, uh, 40, 60, 80, 100. Okay, let's run. Oh, I haven't signed. Okay, this one keep on moving. This one is not working. So meaning that you need to change this one. Change to one. This one LED only. Okay. Right now it's actually not on not being changing its color to green light because this one the random number there's no 50. Okay, tak ada pun yang kena 50 lagi, yang selalu pergi kat mana, tak ada. Okay, because this is a random number. Okay, okay, this one is actually gauge. Okay, I want to show you this one. The one that you have is what we call as a horizontal gauge. This one. Okay, have this custom gauge, where in custom gauge you can actually custom setting, do the custom setting like the LEDs, like the display gauge in like a digital display in the car. You can do that. Okay, but this one is too time consuming. Let me check. Okay, for example, this one. Okay, now for example that okay, this one. You have a scale color, so same thing. Yeah. Let's say 20, 21, 60. Okay, this is the gauge. Okay, so okay, you're going to move lah. Okay, it's just that this is the gauge. This is just a pure simulation. It's not being connected with any data from sensors yet, or any switches, or any potentiometer, hardware or physical potentiometer. It's just that whenever you want to change the theme for this gauge, you can go to this one. Okay, edit custom lock. Okay, where you can create or you can adjust or have your own you can have your own theme for this gauge. So let's say that I want to change the edit arc color. Okay, kita keluar lagi. Okay, Okay, change the needle. Okay, so ini tak adalah sebab saya dah delete. Okay, tapi boleh nampak tu lah dia punya yang color tu, transparent tak transparent lah. Okay, understand lah for this one? Okay, I want you to play around. Okay, this is the going to be very useful for you. The first one, the gauge, yeah, this one is a simple one, the toggle and the knob button, and then the scope, the LED, and then I want you to okay, this one dashboard scope display. Okay, another one is that okay, this one. This is the what your input when you run your simulation. Let's say that you want to create to provide to be able to give an input into your work without stopping your simulation or without the need of giving the input inside the MATLAB main interface. So let's say that I have this one sources. Okay, scope. Okay, double click to continue. So this one is actually the okay, the field that I'm going to use if I want to key in input other than giving the input inside the MATLAB interface or double clicking and change the value inside the simulation block. So this is the alternative. This one. Okay, constant value. Okay, let's say that I'm change. Okay, double click. Let's say the value is 100. Enter. So you're going to automatically change the value inside the constant block. Okay, 150. Enter. Okay, then 2000. Enter. So this is how you control your input. Okay. Okay, and then we're going to sign. Let's say for this one, again for the example, paste. So you have 50. Let's say that 51, 52, 53, 54, 55. Okay, ini I'm using an example this one that with the only input that I can key in to change the status value is up to from 50 to 55. Okay, so I'm connecting this one to this block. Confused. Okay, saya nak set ni. Okay, concern one. Okay. So dia sekarang ni I'm having two kind of option because I just copy and paste the previous block. So the original block is still keep the original setting. Okay. And if you're confused, just for this graphical user interface blocks, don't use copy and paste. Always take a new block. Okay. If not, you're going to get confused. So which one that you supposed to use? Okay. So let's say that for example that change the value to 0. Okay, run it. So there is no color. Then change to 51. Change 52, 53, and then 54 and 55. Okay, got it? Understand? Okay, understand? Okay, any questions? Any question? Okay, good. No question. And okay, last thing that I'm going to show you is that the status on this one very useful. If you can use a checkbox, like more the what selection. So the rest of the block, the one that I didn't show you, can explore on your own because it's quite easy. And okay, I want to show you the multi-state image. Let's say that okay, for this one, Okay, multi-stage image being used to demonstrate the state of a system in the form of graphic, in form of picture or image. So meaning that they say that for state number one, going to stand. Let's say for example, state number one is going to show you its position in A position, state number two B position, and then state number three C position. It's just that when your state keep on changing continuously and rapidly, so you can see that the changes of these images in this multi-state. Okay, for example, I'm going to show you. Um, Sekejap saya nak tukar ambil gambar apa Um, okay, control lah. So let's say I'm giving you a simple example. I'm making this umbrella. So, image one. Okay, let's say that one state only what color? Biru lah. Okay, okay, tak payah lebih kurang lah. Okay, this one state number one. Save as PNG. Image one. Okay, then save as. Okay, so I'm still going to use the random random number. So I'm just going to switch on this state randomly, either one or two, and then this one or two going to change the image continuously. So when we see it in real time, it's like it's like a spinning. It's going to looks like it spins. Okay. Uh, Sources. Okay. Okay. Select signal. So I'm going to select this signal. Okay, going to ask you state one. So I'm going to select the first image, which is a desktop image one. Time and it's uploading. Okay, it's image two. Sorry. Okay, then right, then apply. Okay, so we just one, tak lah, sekejap. I'm using a wrong block. So which one can I use? Yeah, should be this one. Hold on, I'm looking for a suitable block that can show the repeating. This one. Yes, this one. State 1, 0. Okay, I'm changing the state because right here in the past with modulations doing it changed the value changes from 0 to 1. So I'm also changing this value over here too from 1, 0. There you go. So ini dia tak tukar lagi lah. Yeah, see? Ni cepat sangat. So you cannot see. So I need to slow down the sampling time for the transition to see the image clearly. So I just need to select 0.5. Oh, that. There you go. Can you see that? So keep on changing. Right now, ni sebab apa? Dia punya ni tak berapa nak ni lah. Okay, basically kalau macam if this multi-state being connected to your your data, so you can actually set for range. You can actually simulate lah for certain system which will be represented by a range of values. So meaning that these values you can show that actual conditions like this. So you can show the image. So within for the values within this range, you can show the values is like this. Okay, so this is just example, and then the image you see here is not that big because I'm just make a random image. So any questions? Any question? Okay, cuba buat dulu awak punya play around. Nanti dalam okay in at okay good. Okay, then I will just play around with the block. Try to copy what I just show you right now. So at 4 p.m. I'm going to start to integrate this GUI graphical user interface with the Arduino Simulink. because for Arduino Simulink, the setting is there's one setting that you need to make it done, because if you don't do that setting, you cannot run this graphical user interface blocks while running your Simulink block. Okay, okay, and I'll come back at 4 p.m. So meanwhile, I can play around with the dashboard block. Okay. I will continue now. I will make a setup for the Simulink graphical user interface integrated with the Arduino. I'm trying to control the operation of the LED on board of the Arduino board, as well as the Arduino board being integrated with the accelerometer. So at the same time, also going to monitor the acceleration data. Okay. So while waiting for me to set up the graphical user interface, so you can start playing around. So if you have problems, so you can ask me. Mm.
So what is the name of the graph again, sir?
Scope. This one, dashboard scope.
Dashboard scope.
Yeah. Okay, now I just finish the creating graphical user interface, which I think I want. So basically, on your left is the interface that I use to control the operation of the LED, while on the right is actually the scope to monitor the association data. So I just finished the graphical user interface. Now it's time for me to assign this block with this appropriate or necessary symboling block before. Okay, so I'm going to associate these blocks with the symboling block first. Uh, okay, okay, I'm going to associate this block with this one. Okay, then I'm going to associate this block with also this one, with one, the state one is going to be in green color. Okay, then for this one I'm going to assign the same one, this one, same block, just that with the state 0 I'm going to assign with red color. Okay, this is just for the LED. Now I'm going to assign the block for the association data. So for the block for the association data, since that we are integrating this one with the Arduino, so we need to use the Arduino block, which is for the analog input block. Analog input block. So I'm going to assign this one. Oh, this one is 4095. So I'm going just SG. Okay, so I'm going to do the calibration in advance. Okay. Okay. 1/4095. So this one, the unit for the acceleration is G's. Okay, so I'm going select this one. So I'm going to select this signal line. Instead of this one, I'm going to select this one because this one is actually the one that already been through the post processing. Okay, so I'm going to change the color to green. Okay. Okay, now, okay, I'm not going to hide this simulink block first because I want to see if these things working or not. And my Arduino, hold on, let me check for the camera. Okay. Okay, can you see the what? The setup, the Arduino setup. Okay, okay. So this is the accelerometer. Currently I'm connecting it only to the Z-axis channel, and then the LED is just that for the LED I'm going to use the onboard LED of the Arduino. Okay. Now back to the um, graphical user interface in the Simulink. So I want to show you whenever you want to use the graphical user interface using the dashboard blocks in Simulink with the Arduino. There's one thing that you need to set up other than a typical setup. Okay. First, you need to change, of course, as usual, change the stop time to infinity. Go to the. We need to set up the hardware. Okay, the fixed tab, server details, change the 05. Okay, and then for the hardware implementation, so I'm using Dware. So just select Dware. So if you're using Uno, select Uno. Okay, let me check for the COM port. COM4. Okay, in hardware configuration for the Simulink, okay, this is the important step. So when you want to use the dashboard blocks, and at the same time controlling the Arduino, so you need to check or you need to make sure that in the external mode, okay, previously we did set on the serial. This one, if you're using normal, let's say that you want to monitor your data using normal scope, okay, this one we just use a normal serial, okay. But to use the dashboard blocks, you need to change the setting to XCP on serial, okay. And then this XCP on serials only set when you want to use the dashboard block. And if you use this also, if you use this XCP on serial, only to monitor the scope data using the scope, your what you won't be able to see the data because you have a wrong setting. Okay, same thing for this one. Use this one for serial. Use we use serial setting when you want to see the data via normal way, which is through the scope, simulink scope. But for XCP data, we use this XCP on serial setting when we want to monitor the data, or we want to use the dashboard blocks in with the Arduino. So use this one. Okay, this one very important. If you don't set or forget to do setting, then it won't work. Okay, okay. Okay, now rechange. So let me save this one first. GUI LED. Okay. So let's go to modeling. Go to hardware. Okay. Let's build and deploy. I'm not sure for this one because yeah, last time this one should be sufficient because if you put too many display blocks from dashboard library, and then your Arduino will be burdened. Okay, some of you it might not work on your Uno, and it might only work on my Dual because Dual has a high capacity of processing and memory. Okay, if you want to use your Uno to practice this dashboard, just limit your dashboard blocks only to a few, only two or three, just to maybe yeah, to control the LED still can, I think, but to monitor the data, then other things, and then you're going to put your Ono in yeah, under burden. Okay. Okay. So I hope that there's people recording my session. So ada kan yang record? Ada tak yang record? Okay, ada, good, mas. So nanti awak tolong share dia punya link recording ni dekat dekat dalam group lah. Okay, so sekarang ni dia dah running. So ini saya punya data station. So sekarang ni data dia sampling dia tak bawa betul lah, and then bukan sampling tak betul, saya punya sensor accelerometer ni yang tak betul. Okay, so dia tak betul tapi cukup untuk display data lah. So saya nak demo je. So awak boleh nampak saya punya setting Arduino sekarang. Nampak kan? So sekarang ni LED saya dah menyala. So ni kalau saya off. Oh okay, sorry. Yang LED saya tak assign lagi dengan Arduino block ni, saya lupa. Sekejap. Okay, basically kat sini dah booking. Tapi untuk data acceleration ni, kalau awak tengok, okay, bila saya gerak, so adalah dia punya data dia. So saya gerak dalam acceleration. So value dia tinggi lah. So ini nak properly calibrated just to demo the step only. Okay. So ini saya stop balik sebab saya nak tengok dia punya, saya nak betulkan dia punya pin ni. Sepertinya LED menyala lah. Ini saya tak letak dia punya Arduino block lagi. Okay. Hardware, so saya stop. Okay. So ini dia punya ni lah. Pin out. Pin number 13. Okay. Okay, same since that I'm adding up the new block, so I better to deploy. Okay, it's running. So if I switch on the LED, okay, the LED is okay, it's working. So you can see this is okay, the LED now is off. Now the LED is on. Okay, this off. So this is the LED. Okay, it's on and off. Okay, so basically we can control both hardware and sensors using integration between Arduino and Simulink. Okay, it's just that you need to find the powerful Arduino, which is in this case the most high performance Arduino board is the Dual, because the highest capacity in terms of processing is MKR 1000, but it's just that the MKR 1000 it don't have enough what analog input channels, and there is no digital output analog output channel, which is DAC 0 and DAC 1. Okay, and then furthermore the MKR, usually we use MKR 1000 for IoT, so we cannot and then the only reason that Dual is a better option for our project is that it has more channels of analog, okay, compared to MKR 1000. MKR 1000, yes, is powerful than the Dual, but it has a limitation in terms of channels. Okay, any question about this graphical user interface with a MATLAB Simulink Arduino? Okay, any question? So I think you can play around with this, because for those who have, I think for your project, if you involve monitoring system, if you want to control electronically, or okay, you can use this Arduino Simulink and what these features, which is the dashboard block. Okay, and then I think there's a six group. I think each of group, if you want, you can also integrate this a graphical user interface to monitor each subsystem performance. I'm not going to tell you how to do it. It's up to your own initiative. So it's just that for groups that did it, you're going to get extra marks. Yeah, for group who didn't, you won't get extra marks. That's it. Itu je. Okay. So nanti saya akan bincang dengan Dr. Izari lah, as to make it compulsory for each subgroup or what. Okay. Okay, any questions? Diam ni semua ni. Pergi mana? Tidur ke?
Tengah buat sekarang.
No questions lah.
Okay, so sekarang tengah buat ke apa? So awak buat dulu. So play around. Kalau ada question boleh tanya saya lah. So kita sekarang ni dah lama 40 lah. Okay, lagi 5 minit lagi. So okay, ini ada yang kawan awak tanya, do we need to do GUI for our subgroup? Okay, contohnya lah, awak sekarang ni subgroup ada apa? Ada steering, ada powertrain, ada battery, ada right handling, lagi apa lagi? Lagi dua, integration, kan? Okay, dia sebenarnya okay, setting and structure. You can actually create this kind of monitoring system for each subgroup. Okay, let's say that for steering system, you can actually for okay, brake. Okay, let's say let me go for powertrain lah. So basically for powertrain, of course you can see by doing this one, you can see the system should be about monitoring the performance of the battery system, the power consumption, and the discharging states. Okay, so for example, for powertrain, for right handling, what you can do is that you can see the monitoring, you can monitor the data while the vehicle is moving. Maybe you can monitor the roll. Okay, you can monitor the yaw angle, pitch angle, right comfort performance, where you can calculate the one. So, okay, and then for this integration, this one under vehicle structure, right? This one integration. Okay, saya rasa yang untuk yang vehicle structure pula, awak you can integrate because your vehicle structure need to be you need to install sensors to monitor the flexibility of your frame while it's moving. Okay, that data can be transmitted via IoT or wirelessly. That one can be done. So I think I can show you. Okay. And then for steering brake system, for steering, you can monitor the steering angle. So all of this data. Okay, and then one more thing. Yeah, I think I should share you how because right now what I am doing right now is we are actually monitoring and controlling actuators and sensors using a wired connection. Okay, next time I'm going to show you with how to um, do everything and do the what wireless data transmission, where we can monitor this data can be transferred or transmitted and be monitored using your phone and your laptop. Okay, same thing. We still going to use the MATLAB platform, but that one, yeah, I want you to make sure you do this one first because that one is a bit advanced. So if you don't master this thing, I cannot proceed with the wireless data transmission using the IoT approach. Okay. So basically, every subgroup you can create this kind of monitoring system using the Arduino. Okay. It's just that I'm going to discuss with Dr. Izari first. Is it yeah, because because right now you are in what auto design 2, which is 2 credit, and then for this semester only. So you still have another semester, which is next semester, which is you have a lot of time. Okay. So I will discuss this one with Dr. Izari first. Okay. Any other questions? Okay, clear. Okay, if there is no questions, then so Muaz, so please share the video, and then yeah. So if there is no other questions, we dismiss this class. So see you next week. Okay. Okay. Assalamualaikum. Good evening, and from team, selamat berbuka. Okay. Nantilah pukul 7, bukannya asar. Berbuka time maghrib, bukannya time asar. Okay. Thank you. Okay. Assalamualaikum.
Thank you, sir.
Okay.
Thank you, Doktor. Selamat berbuka, Doktor.